Here is two more examples related to this zeros of polynomial question. This one, it just show you my zero x equal -1 or 2. So in other words, the zeros of polynomial can be fraction number. Is one solution of this polynomial. Find the other solutions. Okay, again, we know the possible solutions is from the factors of my factor of my constant number, -9, over factor of my coefficient of my leading term. So factor of -9 at least here, factor of 2 at least here, right? And the already tell me -1 over 2 is one of the 0. So I'm testing 1 over 2 first. Why? Because then I can break down, reduce the power, then break down to next level. Okay. Using the synthetic division, we got my first, right? First, using this -1 over 2, testing, I get here is my lower bottom. And then I continue testing. I choose the easy one, choose 1. Okay, if I choose 1 test, repeat the again, then we bring this 2 down, right? Using the simplicity. Then 2 multiplied by 1 give me 2, plus this -2 give me 0. So at the end, we get a 0 as a remainder. So that tells me 1 is the solution. So now we already know 0 has a -1 over 2 and a 1. In other words, I can write my fx equal x plus 1 over 2, x minus 1. Then the next multiply here is from my division. This one represents my leading term in the last factor because this 2 gave me x squared. The given polynomial degree is 4. So here it should be is 2x to the square, right? And here represent x to the 1 power, but it's 0. So just became a 0 plus 18. So my polynomial can write 2x squared plus 18. And then we just need to figure out what's the solve 2x squared plus 18. So this equals 0, right? I move it. I do a little simplify because I have a 2 as a common factor divided out. Is x squared plus 9 equals 0. Then give me x plus minus, because this one is x squared equal -9. X equal plus -3i. That's my solution. Next example, we using the theories. You see he gave find the polynomial of lower, ask for the lowest degree with zeros of 3i and 2, and multiplicity is 2. So based on all this, we already can write, okay, my fx equal, using the theory here, The linear factorization theory tells us given this polynomial always can write as the leading term coefficient multiply all these linear zeros. Right. Okay, so we go back here. Let's just tell me I can write the given function as a coefficient. Then it already tell me the 3i is the 0. Then we need to know the conjugate of 3i is negative 3i, also 0. So you can write a x minus 3i, x plus 3i, and 2 with multiplicity 2. That means x minus 2 have a power 2 here. We only need to figure out what is the lowest degree. Actually, you really no need extending. If you extending here is okay. If you don't, see here's my highest powers 2. Here power is 2 2. So this one give me the highest power of the polynomial. So in other words, the lowest degree of this one is 4. Next example, I like it. It's kind of combined the concept and not too much calculation. Okay, it said, first of all, tell you this polynomial degree is 3 with zeros negative 2i and 4. If with zeros negative 2i, then immediately tell me positive 2i is zeros too. And the polynomial must be also satisfy the condition that when p function p, right? In other words, when x equals 0, function value is 32. Ask me write this polynomial. So question is ask me find what is equal. Okay, we set up based all the given information, right? So because it's 0, negative 2i and a positive 2i, that means one of the linear factor here, and also 4 is 1x minus 4. His degree is 3. That's it, because it's already x to the cube is degree 3. So in order to find this polynomial, the only thing I need to find out is what is a equal. Okay, and how to find a equal using this one. Because when x equals 0, the polynomial function equals 32. Here's my polynomial function already. That just means a multiply 0, 0, 0 minus 16 equals 32. Like, tell me, right? My solve this simple equation give you 2 equal negative 2. So here is my final answer. Next question, we're using this to recall a rule of how to counting a given polynomial's possible real zeros and possible negative real zeros. Okay, so the way we counting positive real zeros is we counting the given polynomials you have a couple, few terms, right? Just counting how many times they changing the sign from each term. For example, here, positive, negative, 1. But negative to negative didn't change, right? So negative to positive twice, and then positive to negative change 3 times, and then negative to positive to change. So the change sign is 4 times. That means my possible positive real number, real zero, is 4. Then how do we count possible negative real zeros? That means we have first of all rewrite the polynomial as f negative x. So we change the given here is positive became a negative x to 5. And then given here, you careful here, you may say, why this didn't change to negative? Remember, it's the negative x false even power, right? And even power still gave me positive, so the negative x fall plus negative go the cube out power that be changed to positive, and here even power doesn't change, and then negative became positive plus 300. Then we check that here down here doesn't have a sign change, right? The negative not change, but this one negative to positive change once, then the following all positive didn't change the sign. So only change signs only once. So that tell me the positive negative real number is just 1. Okay, and I ask you, what's the total degree, number of image numbers? Image numbers is counting from the total degree. Total degree is 5, right? Minus the possible real zeros. Okay, so total degree is 5. Also, because we remember if there's an imaginary zeros, it has to be paired, right? In other words, always the imagine zero and is conjugate together will be the function 0. So it's never can be odd number. So in this case, my degree is 5, and if we subtract its 0, 4, give me 1. So it's an odd number, so cannot be odd number. So that just tell me the imagine 0 is 0 when the positive real number is 4. And these numbers of zeros always reduce 2. If the highest can be have a 4 positive zeros, and the next possible is have a 2 real zeros, and next is don't have a real zeros. Okay, and this one just 1, 1, 1 because they only have one change. Okay, so then in this case we have a degree is 5, but have a 2 real and 1 negative real. Subtract give me 2 imagines. Same thing here, we don't have a positive real, we have 1 negative real number, and total degree is 5. Subtract 1 give me 4 imaginary zeros. Here is one we need to know. All is also based on the basic for the polynomial function. If degree is n, then that means they have n zeros. The zeros can be positive real -0, all complex. Imagine this together. If the polynomial degrees n, you have n zeros.